Hey everybody, it's Mrs. Smith here, and today we're going to start Unit 6, Lesson 5. So that's on page 333 of your math books. So go ahead and get that ready, and then you can play the video when you're ready to get started. So, in the past couple of weeks, we've been introduced to different shapes in geometry, mostly two-dimensional shapes that have length and width. We've talked a little bit about triangles and different quadrilaterals, and today we're going to be talking about area and perimeter of mostly rectangles. There's a couple other things that we'll address, but mostly rectangles. So before we get into it, I just wanted to give a little brief introduction. So I have here a rectangle that I drew, and on the inside, where I have those orange lines, the inside of the shape is called the area of the shape. You can think about an area rug. That kind of helps me remember. An area rug covers a bunch of space on the floor. And then to find the area of a rectangle, what you need to do is the length multiplied by the width. And you'll notice that I did a cursive L here. That happens a lot in math when a letter looks similar to a number. We didn't want people thinking that it was like a 1, so we just do a cursive L. So length times width equals the area of a rectangle. And then the perimeter is the distance all the way around the shape. So sometimes in like an action movie, they'll say, secure the perimeter. That means if they have a fenced-in area, they want to make sure that there's no holes in the fence or no one can get out through a gate or something like that. So the perimeter is the border around the shape. And to find the perimeter, what you need to do is the length plus the width plus the length plus the width. And that's the perimeter. Another way to do it is do the length multiplied by 2, because there's 2 of them, right? And then add that to the width, multiplied by 2, because there's 2 of those. Either of those will equal the perimeter. You just have to do one or the other, but in some situations it's easier to do one or the other, so both ways are good to go. All right, I know that was a lot of information, but that's what this whole lesson is about. So if you're still confused, don't worry, we're going to get into it a little bit more. So on page 333, there's a letter to your parents. You can show this to your parents when they're available. It says, your child is currently learning about perimeter and area. Students begin to investigate the area of a rectangle by counting the number of unit squares inside the figure. Students also find the perimeter of a rectangle by counting the linear units around the outside of the figure. Students develop methods to find the perimeter and area of a rectangle as shown below. And then here's the example. The perimeter is the distance around, and so you add up the side lengths, making sure you don't miss any of them. And then with the area, this should remind you a lot of arrays. It's almost the same thing, right? How many rows and how many columns. And we're also using units of measurement, so we'll be saying square inches or linear inches. Perimeter is in linear, and then area is square, because we are talking about how many squares there are. It continues to say, students draw rectangles that have the same perimeter but different areas, and rectangles that have the same area but different perimeters. They discover relationships between perimeter and area, such as that for a given area, the longest, skinniest rectangle has the greatest perimeter, and the rectangle with the sides closest to the same length or the same length has the least perimeter. Students create shapes with tangrams, explore area relationships among the tangram shapes, and it uses shapes as improvised units to measure area. Throughout the unit, students apply what they have learned about perimeter and area to real-world problems, and your parents can email me if they have any questions. So, now we're on page 335. Oh, and the letter is in Spanish if your parents read Spanish. Okay, so we're considering that each length between the dots here is 1 centimeter apart. Now we're not counting the dots, we're counting the length. So that's 1 centimeter and this is 1 centimeter. So that means if we count right here, that's 1, 2. So this, let me erase that there. This is 2 centimeters right here. So is this. Oops. This length is also 2. 2 cm. This length here, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. This here, we're also going to count the length. 1, 2, 3, 4, 5, 6, 7, 8, 9. So both of these are 9 centimeters. So, what part of the rectangle is the perimeter? Remember, it's the distance around the outside, so it's the all side lengths added up. What part of the area is, what part of the rectangle is the area? The space inside. So now we're going to find the perimeter. So we're going to choose the side to start with. We'll start right here. So this side is 2. And then we're going to add that to this side here, 9. And then we're going to add that to this side here, 2. And add that to this side here, 9. So I'm looking here, and that's going to be 11, and this is also going to be 11. And when you add those up, we get 22 centimeters. That's the perimeter. Now to find the area, it's the length times the width. So the length here is 2, and we're multiplying that by the width, which is 9 cm. Don't forget our units there. Oops, that looks real messy. Sorry. 2 cm times 9 cm. And we could actually even count the squares inside. So let's go ahead and do that. So if I just draw straight lines based on these centimeter tick marks, I should say dots. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if we remember our math facts, 2 times 9 is 18. And here we had one row of 9 and another row of 9. And that should all make sense. It is 18 centimeters squared. So square centimeters, because each of these is 1 square centimeter, and there are 18 of them. A square centimeter, that's kind of rectangular. And then the linear centimeter is just like the line, right? Only one dimension. It doesn't have length and width, it just has one. Okay. So, now we're going to move on to number 5. Draw a rectangle 5 centimeters long and 3 centimeters wide on the dot paper. Find the perimeter and area. Alright, so because there's only 4 dots here, we really have to go one way. So I'll start at this corner. 1, 2, 3, 4, 5. 1, 2, 3. Looks kind of chunky, but just imagine it's straight. Alright. There we go. Now, let's go ahead and label our sides. This is 3 centimeters, 3 centimeters. This is 5 centimeters and 5 centimeters. So remember, to find the perimeter, it's the distance all the way around. So that's going to be 3 plus 5 plus 3 plus 5. And if you're having a hard time remembering which one is which, perimeter is a longer word, so you can kind of think of it as like perimeter. I guess that's one way to do it. So you could use your doubles fact, so 5 plus 5 is 10, and 3 plus 3 is 6, so we have 16 centimeters, not squared. And then the area, remember, is the length times the width. It's the space inside the shape. So that'll be 5 times 3, which is 15 centimeters squared, or square centimeters. And if you count the squares, there are actually 15 inside. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, there you go. So it says, explain how you found the area of the rectangle in exercise 5. Well, we did it 2 ways. One way was we multiplied, oh my gosh, sorry about that, the length by the width. We also counted the squares. All right, let's continue. Okay, so now we're going to find the area and perimeter of each of these figures. If you're feeling confident, you can pause this and go ahead. If you want, you can work along with me. So let's go ahead and label our sides. This one, 1, 2, 1, 2, 3. This is 3. 1, 2, 1. Whoops. 1. Come on, pen. 1, 2, 3. This is also 3. Wow, it's not working. I'm so sorry. CM. There we go. And it's 3 all the way around. So it's 3 plus 3 plus 3 plus 3. And if you remember your multiplication facts, 3 4 times is 12. There we go. So that equals 12 centimeters. And then the area inside, it is still 3, right? 3. So that will be 3 cm times 3 cm, which equals 9 cm squared, 9 square centimeters. All right, number 8, here we go. So count this side, 1, 2, 2. This side, 1, 2, 3, 4, 5, 6. And remember, we're not counting the dots, we're counting the segments between the dots. So this is also 2, and then this is also 6. 0 centimeters. So the perimeter is 2 plus 6 plus 2 plus 6, and that equals 16 centimeters. And then the area would be 2 times 6, which equals 12 centimeters squared. All right. Now, this one's a little different down here, number 9, but all we need to do here is just chunk this into non-intimidating looking shapes and lengths, and we're going to be fine. So right here, 1. This length is 1. This length is 1. This length is 1. This length is 2. This length is 1. This length is 1. That length is 1. And this length is 1, 2, 3, 4. So the perimeter is 1 plus 1 plus 1 plus 2 plus 1 plus 1 plus 4. I'm running out of space, but it's 3 right here, plus 2 more is 5, plus 2 more is 7, and plus 4 more is 11. Oh, I missed one. Oopsie. I missed this one right here. Plus 1, so it's 12. 12 centimeters. And then the area for that, what I'm going to do is I'm going to make this one shape, and then these are also separate shapes. So this here, we have a 2 by 2. 2 times 2 is 4, and then each of these are 1. So we did 2 times 2 plus 1 times 1 plus 1 times 1. 1 times 1 is 1, 1 times 1 is 1, plus 4, so that is 6 centimeters squared. All right. Now for the perimeter on this one, I kind of just want to count as I go around. That way I will not run out of space on my lines. So I'm choosing a starting point. I'm going to make it a different color so I don't get confused. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter is 12 centimeters, not square, just linear because it's like a line. And then for the area, I'm going to break this into squares and just count the squares. So 1, 2, 3, 4, 5. 5 centimeters squared. All right. So, number 9, let's see. Wait. Oh, we just did 9 and 10. Okay, good. So 11, here we go. For the perimeter, I'm just going to count it for this kind of shape. But you could label it, but I'm going to make a starting point right there. No, I think I'll label it. Okay, so this is 2. And then 1, 1, 1, 2. 1, 1, 1, 2, 3. 1, 1, 1. Whew, okay. So I'm going to just count all my ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones plus my 2 twos, which is 4, plus my 3. So that's 9 plus 7, which is 16 centimeters. And then my area, let me neaten this up a little bit. I'm just going to chunk this into squares and count the squares. And I'm using the centimeter dots to make the squares. So count my squares. 1, 2, 3, 4, 5, 6, 7. 7 centimeters squared. It's just the space inside that shape. All right. For my perimeter, let's go ahead and do that. On number 12, we got 2, 1, 1, 1, 2, 3, 1, 1, 1, 1, 1, and 2. Alright, let's do all the ones first so we don't skip any. I find sometimes when they have these like little chunks like this, it's really easy to accidentally skip one. So you got to be very careful. 1, 2, 3, 4, 5, 6, 7. So 7 plus, got my 2 twos, which is 4, plus that 3. 7 plus 3 is 10, plus 4 more is 14. just linear centimeters. And then for my area, like I did before, I'm just going to chunk it out. Make it easy for myself and for you. So chop, 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 chop. Count the squares. 1, 2, 3, 4, 5, 6. 6 centimeters squared. Okay, let's go ahead to the next page. So for this page, on your paper, you probably do want to cut out all these squares. I can't do that with this kind of video, so I'm just going to draw them in. Okay. So when you're laying them down, it's really important that you make sure there's no gaps and there's no overlaps, and then draw in some lines to show the unit squares, which are the same as the other squares. And then you can count the squares and then say what the area is. So I'm going to move to the next page so I can do that. So when I measure this, I can see that this is 5 inches, that dimension, the length, and then it is 3 inches wide. So I'm going to freehand this because I'm on an iPad, but you might want to use a ruler. So here we go. Not bad. Okay, and then 5. So 1, 2, 3, 4, 5. That's not terrible, but not the best. Okay, so hopefully when you put your squares on, it looks pretty much like this. This is called tiling because it kind of looks like floor tiles or counter tiles. Making sure there's no gaps and no overlaps. So if we have 5 and 3, a 5 by 3, some might say, well, let's count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Up here when it said, what's the area? It is 15 inches squared. And then if we go ahead and use that formula, the multiplication formula, the length times width equals area, we can do the length, which is 5, times the width, which is 3, and that, if you remember your math facts, is 15 inches squared. And remember, we were saying square inches because we're talking about literal square inches, inches that are 1 square on each side, and there are 15 of them. Okay. So use those same squares that you have to lay on this rectangle. I'm just going to measure. So I've measured, and this is 1 inch, and then this is 4 inches. So you should have something that looks about like this. So if we count the squares, 1, 2, 3, 4, we have 4 square inches, and you'll notice this time I wrote it with SQ and then IN. It's the same thing as 4 square, oopsie, 4 inches squared. Means the same thing in math. And then the equation for that would be 4 times 1, which equals 4 inches squared. It could also be written as 1 times 4 because of that commutative property of multiplication. Still 4 inches squared. Okay. So either one of these is good. All right, for this one, go ahead and lay out your squares. So for me, when I measured, I got 5 inches by 2 inches. So I'm going to just chop that freehand. Not bad, not bad. And then 1, 2, 3, 4, 5, So let's count those squares. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 inches squared. And the equation, you could either do 5 times 2, and that's 10 inches squared. Or you could do 2 inches times 5 inches, and that's still 10 inches squared. Okay. How many 1-inch unit squares are needed to cover a rectangle that is 7 inches long and 4 inches wide? Now, you could go ahead and set that up with your inch squares and make one that's 7 by 4. Another way to do it would just be using that formula to figure out the number of square inches. So our formula is length times width, so that would be 7 inches times 4 inches. Hopefully you remember. That would be 28 inches squared. So that would mean 28 square that are 1 inch by 1 inch. And then what is the area of a rectangle that's 7 inches long by 4 inches wide? Well, it would be, we kind of did it right there already, 7 times 4, which is 28 inches squared. That would be the area. That would be the amount of space inside that shape. All right, so that's it for today. There's an activity on Think Central for you to complete, so go ahead and complete that, and then see you next time. Bye-bye.